All right, today's lesson, we're just doing a quick review, quick recap of 11.1 to 11.4, and then we will move, 11.1 to 11.5, because algebra tiles will be included on the quiz. Okay, so here we're looking at our first example here. We have 7x cubed minus 3x squared plus 5x. So this is a polynomial. It's already in simplified form. There's no like terms we can collect here, so it's already in simplified form. So we're trying to figure out what type of polynomial this is. So there are three terms. So 1, 2, 3. There are three terms in here, so we would classify this as a trinomial. And next we want to figure out the degree of this polynomial. So the degree of a polynomial, again, is counting, or not counting, but adding the exponents. The largest exponent in a polynomial here is x cubed. Sometimes you'll get examples where the term may have more than one variable. So in that case, it's the greatest sum of the exponents in any single term. And that will give us the degree. All right, but this is a degree of 3. All right, and again, it's a degree of 3 because of the exponent. The largest exponent is a 3. Okay, let's take a look at another example. All right, let's take a look at this one here. Let's say we have 3x to the power of 5 plus 4x squared y squared minus 5y cubed. And let's say we are also trying to figure out the degree of this polynomial. So first of all, there's three terms in this polynomial. First term is 3x to the power of 5. Our second term is 4x squared y squared. And then our last term is this one here, the 5y cubed. And so there's three terms, so we know it's a trinomial. So looking at the degree, we have to look at the sum of our exponents. So in this term, this is a degree of 3. This term, it's 2 plus 2, so this is a degree of 4. And then this term has a degree of 5. So we always look at the largest degree. So this degree would be a degree of 5. So this polynomial has a degree of 5. All right, so for this question, we have three brackets, and they're all just being added. There's no number in front of the brackets, so all we have to do is open up our brackets and then collect like terms. So we have 3x squared plus 2 plus 7x minus 8, and then plus 4x squared plus 5. All right, so collecting like terms, sometimes it is a good idea to have some different colors, so you can underline the ones we are going to collect together. So we have a 3x squared and a 4x squared we can collect together. So we get 7x squared. Next, we have 7x, and there's no other term with the x variable. So it's just 7x. So plus 7x. And then we have 2 minus 8 plus 5. So 2 minus 8 plus 5. Again, use your calculator if you are struggling with integers. And I get a minus 1. All right, so that is now the simplified expression. So 7x squared plus 7x minus 1. All right, so our next example here, we're looking at 4 multiplied by x squared minus 1. That's our first bracket. Our second bracket here, we have to apply this subtraction to everything to the second bracket. And our third bracket is just a plus, so all we have to do is open up the third bracket. All right, so let's multiply that 4 to everything inside that first bracket. So 4 times x squared, that is 4x squared. Then 4 times negative 1, that is minus 4. Then we have to apply this subtraction or this minus or this negative to everything inside of this bracket. And basically it just changes our signs. So it's going to become minus 2x squared and then plus 3x. And our last bracket, all we have to do is open up the bracket. So plus 7x squared and plus 6x. Okay, and now all we have to do is collect our like terms. So I'm going to start with our largest exponent, which is x squared. So we have 4x squared minus 2x squared plus 7x squared. All right, so 4 minus 2 plus 7, that gives me 9. All right, remember to always apply the sign that's in front of that term. So it's a minus 2, this is a positive 4, and this is a positive 7. So that gives me 9x squared. All right, next we have the 3x and the 6x, which can be combined together to give me 9x. And then we are just left with the negative 4 or minus 4. And that is it. All right, so our next question here, we're looking at algebra tiles. So recall that if it's a shaded tile, it's a positive, and if it's an unshaded tile, it's a negative. So if I write down everything for each tile here, this is a negative x squared, this is a positive x squared, and then we have a negative x squared. This is a plus x, a minus x, and a plus x. And then we have 5 negative 1 tiles. So negative, minus 1, a negative 1. So there's 5 of those. 1, 2, 3, 4, 5. Yep. All right. So then you can collect your like terms and you can do it that way. The other method was if you have positive and negative tiles, they would cancel out. So here a negative and a positive, that would cancel out and leave me with a negative x squared. Here, positive and a negative would cancel out there. This would leave me with a positive x. And then we have 5 negative 1 tiles. So that would give me minus 5. All right, so our expression here is negative x squared plus x minus 5. All right, so next we are looking at multiplication and division of monomials. And we have covered how to do this when we were looking at our exponent laws. So let's go through some of these examples and hopefully the exponent laws will click in again. So here we have an example. We have 3x squared being multiplied by 4x to the power of 5. So what we're going to do is, first we're going to multiply our numerical coefficients, which are the numbers. So we would multiply 3 and 4, and then we would use our exponent laws. So exponent laws, if we have the same base, so we have a base of x and a base of x, and they're being multiplied together, then we add our exponents. So the answer here, 3 times 4, that gives me 12. And then we have x squared multiplied by x to the power of 5. So we would add our exponents. 2 plus 5, so we would have x to the power of 7. All right, so 12x to the power of 7 would be the answer there. Okay, let's try another example. So we'll call that A and B. Here we have 6a squared b cubed, and it's being multiplied by 5, a to the power of 5, and b to the power of 6. So again, we are going to have to use our exponent rules. Firstly, we're going to multiply our 6 times 5. That just gives me 30. We have two bases here. We have a and b. Same with this bracket, we have a and b. So when applying the exponent laws, make sure the bases are the same. So a and a here. A squared times a to the power of 5. Add the exponent, so 2 plus 5. That gives me a to the power of 7. And then we have b to the power of 3 and b to the power of 6. Same base, you can add the exponents. So it becomes b to the power of 9. Okay, let's take a look at a couple more here. Negative 5a multiplied by 3a squared multiplied by 2a to the power of 5. All right, so we got three brackets here. So negative 5 times 3 times 2, that gives me negative 30. And now if we look at all of our bases, we have an a squared, and a to the power of 5. Remember that if you have an a here, it means it's a to the power of 1. So we have to add 1 plus 2 plus 5, which is to the power of 8. So a to the power of 8. Okay, and then last one here, we have negative 8 ABC squared, and then we have negative 2a squared b, and then c cubed. All right, so first thing, again, multiply the two numbers. So negative 8 times negative 2, that gives me 16. All right, and then we have a to the power of 1. I'm just going to note that there's a 1 there, and a squared, and they're being multiplied together. So we'll add our exponents. So 1 plus 2, that's a to the power of 3. Next, let's look at b. Again, that's a b to the power of 1. 1 here and a 1 here. So that's b squared, or b to the power of 2. And c, we have c squared and c cubed. So 2 plus 3, that's c to the power of 5. All right, so all of these questions here were all multiplication. So as long as you have the same base, we're able to add our exponents. All right, next we're going to look at some division examples. All right, so recall division. So what we're going to do is first, we're going to divide or reduce our numbers or our numerical coefficients, and then we have to use our exponent rules, which is if you have the same base and they are being divided, you can subtract the exponents. So let's take a look at our first example. We have 35x cubed over 7x squared. So the first thing we're going to do is just look at our numbers. We have 35 over 7. That can be reduced. 35 over 7 is equal to 5. Next, we have x cubed being divided by x squared. So the bases are the same. So therefore, we can subtract our exponents. So 3 minus 2 is 1. So I'm just going to leave this as 5x. Okay, our next one, we have negative 15 a to the power of 5 being divided by negative 3a squared. So again, start with the numbers. It's negative 15 divided by negative 3. That is positive 5. And then we have a to the power of 5 and a to the power of 2. Same base, they're being divided. So our exponent laws say we can subtract our exponents. So 5 minus 2 is 3. So 5a to the power of 3. And we have two more to look at. Next we have 27 a cubed b to the power of 5, and it's being divided by 36 a squared b squared. So in this case, 27 and 36, we can reduce. 27 and 36 are both divisible by 9, so that will give me 3 over 4. So that's our fraction reduced. Next we have a to the power of 3 and a squared. So we can subtract our exponents. So 3 minus 2, that is just a. And then we have b and b to the power of 5 divided by p to the power of 2. So we can subtract here as well. So 5 minus 2, that's b to the power of 3. And all of it is over 4 like that. All right, so our last example here, we have 18 k to the power of 4m cubed, and it's being divided by negative 6k to the power of 5m. So we'll start with our numbers, 18 and negative 6. So 18 divided by negative 6 can be reduced to negative 3. Next we have k. It's going to be 4 minus 5, which is negative 1. So k, negative 1. And then m, it is 3 minus 1, which is 2. So it looks like that. All right, but when we were doing our exponents unit, we know that if you had a negative exponent, you bring that down. So here, if we were to do a further step, this would become negative 3m squared, and then the k would become in the denominator. All right, so when you get to math 10, you do have to do that extra step and make sure your negative exponent has been brought down to the denominator. All right, for math 9, if you left it like this would be correct as well. All right, it's just that once you get to math 10, you're expected to make sure that all your exponents are written as positive exponents.